evening for most of you. Well, actually all of you, it's evening. I am Jairam, N2RJ. Officially, I am the ARRL Director of the Hudson Division, but as Dan, my good friend Dan here, who I really admire what he's doing with this Rat Pack group and other stuff, says I'm everywhere. Okay, so today actually I was at a charter school in Sussex County, New Jersey, where I live, and I was showing them how to drone. So I do ham radio. I do lots of different things in ham radio. I run a YouTube channel, also doing videos about ham radio, and I try to do it from an educational perspective, although occasionally I will have fun. And one of the most popular videos I had, actually, believe it or not, it originated in Rat Pack. So the chair of the ARRL RF Safety Committee, Dr. Greg Lappin, NIGL, he did a video on the new RF safety, I wouldn't say new rules, but the changes to the existing rules that kind of brought amateur radio more into it regarding RF safety. So I took that, and then I've been following all the developments. You know, I've been like talking about this all over. So the video is still there. I'm actually going to be doing another video on a new calculator that I've been previewing for a few weeks now from the RF Safety Committee. And I've also been, you know, looking at it. I have some thoughts on it. I want to relay those thoughts to the lab as well, but I'll tell you some of my concerns over it as well. But I'll just go back through Greg's slides to give you guys a refresher. And then you guys can, you know, I'll show you the new calculator, okay, and some of the new developments. So I'll share my screen. I think Dan has it enabled, right?
Yeah, you should be able to do it.
Okay, good. Good. Okay. And okay. Right. Okay. So this is actually given in Rat Pack. So, but I'm going to explain again in case you missed it out, right? And then I'm going to tell you some of the things I learned about it too. And this is Greg's slides. These are not mine. These are from the ARRL RF Safety Committee. I didn't want to reinvent the wheel, so I just take their slides and I explain them, right? And then, well, of course, this is all Greg's stuff. This ebook is available, and David has told us that he might have the publication department make this available in print once again, so you can buy a copy and hopefully just not keep it on your shelf. But it is on PDF, and of course it'll have some updates as well, right, at that thing. The minor changes were made in 2013, and there are no changes for hams. I've read a lot of it. I read through it cover to cover. It's pretty good. I like it. So April 1, 2020, they had new changes to rules published in the Federal Register, and they ended up delaying those rules, presumably through all of this stuff that's been going on that really needs no introduction. Existing stations who complied under the old rules have 2 more years to comply, so until May 3rd, 2023. But if you change anything in your station, you have to comply immediately. So we're going to talk about what compliance means. So these rules went into effect, basically the changes went into effect on May 3rd. So previously, hams used to have exemptions based on power levels to various RF exposure rules. So like, for example, I believe on HF, it was 500 watts, and in some of them, like 2 meters, I think it was 50 watts. Beyond that, you had to do the evaluation. And the big changes, mobile and portable, were completely exempt, and they're no longer exempt. So
can you make your slides full screen?
Is that better? Hold on. This is a PDF. How do I do this?
Oh,
Control L.
Yeah, Control L.
Control L. It will give you a full screen.
Oh,
Do it,
sorry.
or F11 usually does it too.
Yeah, this is a Mac.
Ah,
Ah,
sorry.
I know, yeah, I was like Control L, no, so it's full screen now, apparently, for some reason.
oh, we'll live with it. Go on. Doing good.
Yeah. Okay. So the other thing is that transmitters that are within 20 centimeters of your body has to be evaluated with something called SAR, okay, specific absorption rating, where if you know, like if you purchase an iPhone or an Android phone or some other device that you hold up to your ears like this, they have a document, safety information, that tells you the SAR rating that these have been tested to. And not only that, there's been some controversy with iPhones where independent tests have said that how they actually exceed these illegal SAR ratings. But then again, testing was done and apparently it was not. So people keep watching these. And people keep watching these for several reasons. As Greg said in the last presentation, the FCC is not going to come knocking on your door. Neither is the ARRL. Riley Hollingsworth has better things to take care of, like 7200 and the WARFA stuff and all of that. So he's not going to come knocking on your door for the RF safety stuff. Where this does come into play is if people make complaints. So if somebody sees their towers, maybe a new neighbor moved in and they realize, oh shoot, you have towers there, that thing is going to make me sick. Well, I'm going to complain to, most likely they'll complain to the local town, and then the local town or city will complain to the FCC. And if you have done the evaluations, you're pretty much, you could hold up that and say, well, I comply legally with all the requirements. So, there is no issue here. The other thing, and it comes up properly, and this Fred Hopengarten, actually, who is releasing his new antenna zoning book, K1VR, he's the current New England division director. He said in his book, and he covers in his book, that a lot of times when people go for hearings when people have, like, for example, they need a zoning permit or they need a variance to put up a tower, right? Although you're technically really not supposed to need a variance in a PRB1, but sometimes towns just ignore that and they put that requirement anyway. So you go for a public hearing and people will complain and say, well, you're not complying with the health things and this thing is going to cause a health issue. So that's where it comes into play, where people are complaining that, we are going to have issue with RF exposure. So it's always good to comply with the rules, because if you don't comply with the rules, I mean, it could be used against you. It's the moral of the story. So anyway, back to SAR modeling. SAR modeling, as we probably see in another slide, is a very expensive thing to do, and we're not going to do it. So there's a whole lot of confusion. People think that how this is a whole new set of rules when it's really not. If you look at the chart on the right, and I also cover this in my video, this is a chart of the maximum permissible exposure, basically the plane wave power equivalent power density that that is allowed to basically reach you. And you notice it varies with frequency. So like at the very lowest frequencies, megahertz, you see
no chart. The chart's not displaying.
Really? What are you seeing the slide?
So what we got is the slide for what has changed, and it hasn't moved since.
Okay. Oh, that's weird. I hate when that happens. Hang on.
You may have shared the application, not the screen.
Okay. Then, all right. Let me see if I could share. I don't like to share my whole screen because I often have whole things going on there. But anyway, I'll just do that. Okay. And then how's that?
Yeah, just go full screen so it covers up everything. You'll be fine.
Okay. You see that?
Yep, now we see it. Perfect.
Okay. Maybe I should. Okay. So you see what has changed, right? Okay. What
Yep.
does not change? So the MPE limits, maximum permissible exposure, you have where these limits are actually listed on this chart, and you see they start off at the very low frequencies, 0.3, that's like basically 300 kilohertz, all the way up to 100 gigahertz. They actually have MPE limits. Beyond those limits, you really can't use MPE. And you notice there's a sharp drop off here around, I believe, 3 megahertz. And it goes down here. So this is the VHF region, 30 to 300 megahertz, and then it goes up a little bit and kind of like plateaus out to the top there around 1500 megahertz, 1.5 gigahertz. So they give you basically a number of different parts of body tissue here, where they give you the watts per kilogram, because that's the unit they use to measure. So you have 0.4 watts per kilogram average over the whole body, 8 watts per kilogram average over 1 gram of tissue, 20 watts per kilogram average over 10 grams of tissue in the hands, wrists, feet, and ankles. Now, they differentiate in terms of controlled exposure, occupational control exposure, where you're basically, they use this for ham radio operators too, where you are in control of the radio signal, where you are basically in a working environment. And so it's controlled exposure, right? And they have 6 minutes averaging instead of 30 minutes averaging. Hams, basically you perform your own exposure analysis, and the important thing is do not send anything to the FCC, do not send anything to the ARRL or nobody, because you don't have to, and they don't want it. What they want you to do, and I really recommend everybody to do this, is you either keep a copy in PDF on a flash drive or on your hard drive somewhere, or you print it out and you keep it with a copy of your license and other important papers, and you chuck that in a safe or a drawer somewhere in an envelope. And if somebody ever comes to call it into question, you can pull it out. And then you do it every few years or as you update your station. So these are the previous power limits, right? You used to have 160 meters, 500 megahertz, all the way up to 40 meters. So these are like the lower bands. 500 watts going up onto 40 meters, right? 500 watts of power. So below these, you're completely exempt. Then you see gradually it starts to decrease, 30 meters, 425. Which is kind of funny because we're not allowed to use more than 200 watts on 30 meters. 20 meters, 225, 17 meters, 125, and you go down 175, 50. On VHF, anything above 50 megahertz. I used to run 100 watt, I still run 100 watt VHF radio at times. I actually reach repeaters like 50, 60 miles away on a regular basis. And you notice 77 centimeters and above, it goes up. Repeater stations, if they're not building mounted antennas, you have to use the height above ground level to the lowest point of the antenna, less than 10 meters, and power more than 500 watts ERP. These were the old regulations, by the way. And in building mounted antennas, if the power is more than 500 watts ERP. So these power levels you see in here on the left side are TPO, right? Meaning input power to the antenna. Whereas for repeaters, they have to use the ERP, effective radiated power. And if you don't know what effective radiated power is, basically it is the power from the transmitter plus any gain in the antenna minus any feed line losses. So it's effective power, meaning that you're adding up the gain and subtracting the losses. So, and of course it will vary with direction, because a lot of antennas have lobes. Even omnidirectional antennas, even dipoles have lobes. So previously, mobile, portable, unlicensed were excluded, okay? So that means really your HT was, nobody really cared about your HT. That's all changed now. So these are very conservative. All this says is that these are a very, rough approximations, and you can still be overexposed legally on an excluded system. So this means that even though you're excluded from the categories of exclusion, you can still have a condition where where the actual permissible exposure to you is exceeding the legal limit. And of course, legal limit is a baseline. So the important thing to remember is that you're not exempt from complying with the FCC rules. Okay, you might be exempt or excluded from performing the evaluation, but you must comply with the exposure rules. And that's an important distinction. So that basically means, in my mind, that since we have all these calculators and such, we really should just do the evaluation anyway, because it's so simple to do and it'll have you covered. So what these changes mean, if you did an evaluation and assessment before, you're more or less done. You don't have to do it again. If you are under an exclusion because of the power levels, like for example, you didn't operate more than 500 watts on the lower bands, and you just really did not exceed these power levels, and you're excluded, you might have to do the evaluation again. So, you know, it's always good to do the evaluation anyway. And hams no longer have special treatment in terms of these exclusions by power. We basically now have to perform calculations that deal with exemptions, right? Mobile radios were previously not included in this. Mobile radios are now included. Mobiles are a kind of unique case because you have vehicles with metal roofs and such that'll shield you. And then you have also, even some of the glass has metal in it. You have, like, you know, these defroster wires and such like that. So the ARRL lab has some info on mobiles and such. You have new exemptions based on distance from the antenna to the body. Anything less than 20 centimeters, so like a handheld, you hold up a handheld radio close to your mouth, you must measure or model with SAR, and we'll get to that in a minute. SAR is actually, you need specialized equipment. And as I showed in the video, it's basically a robot that, and if you look at some of these FCC filings for like Yaesu or ICOM, one of these vendors, you'll see that how they have like a dummy head, and that dummy head is filled with gel. And then they have sensors there, and they basically have a probe that goes and injects the, you know, and measures, right? They have dummy head, they have the radio, and then they have a probe that measures, and then they automatically generate a SAR measurement. It's very precise. The other important thing about SAR is that SAR is only valid above 300 megahertz. So what does this mean? As radio amateurs, we use frequencies on 144 to 148, and not forgetting 222 to 225 megahertz. So handhelds for these radios are not covered by SAR. Now, Greg in his last presentation said, and I've been having internal discussions with the lab and the committee, the RF safety committee. Even though I'm not a member of the RF safety committee, I still, you know, I talk with them, I talk with Kermit and these others. If you have a 2-meter handheld, the FCC has said, well, you know, don't worry about that for now. They'll figure it out later. That's kind of a discomforting and comforting thing at the same time. When we discussed at the board meeting, we did not want to have any burdensome requirement for hams. I think the best thing overall is to have hams self-certify and do the modeling based on their own technical knowledge. We don't want to impose a certification requirement for amateur equipment, because this would make things like, for example, Baofeng radios and such illegal for us to use, which is something we don't want to have happen. So these new rules, the exemptions, now the exemptions, not the MPE, right? You have several characteristics. You have the frequency, the maximum effective radiated power, and remember, that is the power from your transmitter minus any losses plus antenna gain, okay? So you have 100 watts, and let's say for simplicity's sake, you have 3 dB of loss in your feed line. Well, even though I wouldn't dream of having feed line 3 dB lossy. So you have 3 dB, so that's 50 watts reaching the antenna. And then the antenna gain, let's say the antenna gain is 10 dB. So I would multiply that by 10, that would be 500 watts. So that's the maximum ERP, 500 watts. And remember, like I said, they have lobes and patterns. Distance between the person and the antenna. And the exemptions do not apply if you're in the reactive near field, which is the wavelength divided by 2 pi if your distance is less than that. Now, the exemptions, and you saw this in probably my YouTube video, you can do them with fairly simple calculations and you don't have to do the full exposure analysis. If you don't qualify for an exemption, or even if you do, you could still perform the analysis, and this will take into account duty cycle. Remember, I gave the example of a duty cycle with a microwave oven. Like if you set the microwave to 50%, it wouldn't just turn the power down on the magnetron 50%. What it would do is it would turn on the magnetron full power for a period of time and then turn it off for the same period of time. So it's only getting 50% effectively, cumulatively. The new exemptions, if you are closer than R meters, right? And to any radiating part of the antenna, and the ERP exceeds the values calculated from the following table. Antenna is closer to 40 centimeters to the person, and if frequency is greater than 300 megahertz, they use these formulas to determine if SAR evaluation must be performed. So we have this example here. I have to send a text to somebody. Hang on here, because yeah. You have a multi-band, vertical in the yard, a sidewalk 15 feet, 5 meters away from the antenna. You have a 100-watt transmitter, 50 foot of RG58, and then you qualify check to see if you qualify from the exemption. Now, if you go back here, they have different frequency ranges where you calculate the threshold ERP in watts. Okay, so for this frequency range, this is basically the AM broadcast band, and also 630 meter band. You have 1920 times the R squared, and R is the distance in meters, not in feet, in meters, and that's how you determine the threshold ERP. This 1.34 to 30, that includes all of HF and also MF, which is 160 meters. 3450 times R squared divided by F squared. And then 30 to 300 VHF 3.83 R squared. And then you go up here, right? So going back to the example, you have the maximum ERP, which is 3450, because this is in the HF spectrum, right? 20, 17, 15, 12, and 10 meters. So that's within the HF. And this formula applies 3450 R squared divided by F squared. And, when Greg set this up, he calculated for the top of the 10 meter band. So he determined the maximum ERP allowed to the top of 10 meters, 3450 by 5 meters squared, divided by 29.7 megahertz squared. So 97.8 watts ERP, right? So that's 15 feet away. He's only allowed 97.8 watts ERP. So next he determines the ERP. So this is the threshold. 97 is the threshold for an exemption, right? If it's anything more than that, he'll need to do a full-blown evaluation. If it's less, he will have to, he can qualify under one of the exemptions. So the ERP is transmitter power minus feed line loss times antenna gain, right? So obviously I mentioned ERP is simply the transmitter power minus the feed line loss plus the antenna gain. Well, he said multiply. So 50 feet at 29.7, 1 dB loss, so 22% of the power is lost. And the ground plane vertical has 0 dBd, so the gain factor is 1. So 78 watts is the final ERP calculation. So the allowed radiated power is 97.8 watts, right? So this is the threshold above that where the exemptions no longer apply, and his ERP is 78 watts. So therefore he's fully below the exemption threshold, and he doesn't have to do a full analysis. Again, this is the bare minimum, okay? In this case, I would still do the evaluation because it's so close. So he changes anything, and then he tries to get closer. He rearranges the equation, does some math to find the distance, and he finds that the minimum distance is 4.5 meters. So he could move the antenna half a meter closer to the sidewalk and still be able to claim the exemption. So what if he can't claim the exemption? You never transmit on 10 meters in that set of frequency range. So you recalculate the frequency. You move the antenna further from the sidewalk, right? But like I said, perform a full evaluation because the exemptions are very conservative. They don't get you, an exact value. They're very, very conservative. And you could find out that actually if you do the evaluation, it will almost always be that the distance is less. The large difference here is the averaging time, okay? Then, if you transmit, for example, 50% of the time, then you have half the exposure. I go back to where I talk about duty cycle. So this is one thing. And this is one gripe I'll have with the ARRL calculator, which I'll explain in a minute. So he has a minimum distances, the frequency divided, the wavelength divided by 2 pi, and these are the minimum distances. So if your antenna is less than this distance and close to people, then you cannot take any exemption regardless, right? You have to do an evaluation. So I explained about the 2-meter handheld. So it's not covered under the new exemptions, right? So generally when you hold a handheld radio, it's less than 20 centimeters of your head. The frequency is less than 300 megs, and SAR testing isn't generally performed at amateur HTs. It is possible, and one thing that Greg was talking about was that it might be possible to use the evaluations for commercial radios that operate in nearby frequencies and apply them to amateur transceivers. But so far, nothing official. There's really been nothing official about this. So all this is under negotiation with the FCC and other parties, and also radio manufacturers are looking to see what they would do. So hams, there is a 2-year grace period, and then the FCC has a very comprehensive bulletin, OET 65. And OET 65B, what you might not know is that this OET 65B, which is the supplement to OET 65, was actually developed by ARRL Lab in conjunction with the FCC. So, the lab did a lot of the legwork, and they did a lot of legwork with RF safety. And the committee is working with the FCC to get everything revised. And the ARRL is working on finding and developing tools. And one of them is this new calculator, which I'll show you, which was actually released today, but we saw it like a few weeks ago and while it was being developed. So other ways you could comply, modeling, like you know about NEC, right? Numerical electrical calculations. And then you can do finite difference time domain. You can do finite elements analysis. And you must take into account the patterns in near field and far field. And of course, SAR is back in the room again. It must account for energy absorption in tissue, and the model must include realistic absorption into the body. So how they do this is they have a gel that is specifically formulated to simulate human tissue as close to as possible. Right, and then they talk about SAR above. So we're not really going into SAR because SAR is something that's going to be out of reach of most hams. MPE, You can use the MPE to estimate SAR. You know, you assume it's a plane wave exposure, and the E field is measured in volts per meter, and the H field is measured in amps per meter, and the electromagnetic power density typically measured in milliwatts per square centimeter. This here is a typical SAR setup, right? They have the mobile phone up against the head, and then the robot will scan the head, and then the computer will then do calculations and spit out a result. You can have more these SAR testing, FDTD and FEM modeling, and you know, you have to have the phone or other device in all sorts of different orientations. So this is another thing that was kind of like a roadblock for us with amateur radio, is that hams don't just use the stock antennas. We actually use a bunch of different antennas on our radios. You know, we're allowed to use different antennas. So we're not really going to be able to have a one size fits all. And it'll be very cumbersome to have certification for all these different antennas that we use. And not only that, the worst thing is they might just tell us, well, you know, you're restricted to the antenna that the manufacturer supplies, and they have to make it so that you can't screw it out and you can't put another one. That's something we don't want. So still working on those with the FCC. They go and talk about costs and stuff. And I mentioned the antenna issue, right? So the FCC is kind of like, so right now these rules are dealing with heating exposure, the heating effect. And what they want to do is the FCC is kind of saying, well, you know, instead of having cumulative effects, you know, we might just do an instantaneous electrostimulation effects below 10 megahertz as instantaneous. So rather than averages over time. And then you see in the chart, it goes, the exposure limits only go to 100 gigahertz. There are hams who operate higher than 100 gigahertz. You know that we have everything over 275 gigahertz. That's wild. And so they want to extend it to 3 terahertz. They want to have new localized MPE limits above 6 gigahertz. Electrostimulation limits would be definitely very bad for us. So we don't want to go there. So, you know, this is just some misconceptions. I mean, the FCC is not out to cancel ham radio, right? They, you know, they like what we do a lot. You know, in conversations I've had with our FCC attorney, our Washington counsel, David Siddall, he said the FCC has a lot of good things to say about us. So it's not that they want to throw us off the air. And the exemptions are actually, they allow us to do, to avoid, you know, very cumbersome and expensive evaluations. No equipment has to be certified in the amateur radio service except handheld transceivers, right? So because of that SAR requirement. The other one is RF power amplifiers, but that's for a different reason. They want to make sure that they don't transmit on CB bands and with high gain. And if you are in a situation where you're exceeding the MPE limits, you can avoid it by, you can place your antennas higher. You can keep people away, like on field day, and especially, and this is especially pertinent to emergency operations. If you have like an HF antenna, you might want to put some caution tape around it and a sign that says keep back RF exposure warning or something like that. You know, they make signs. So you don't want people right up next to your antenna. Like if you're on a scene, you know, or a shelter or something, and you put up an antenna, you don't want people going near to the antenna. Probably they go outside the building to smoke or something. And, you know, they're getting exposed to all this RF. So they're killing themselves with lung cancer, and then they're getting heated up by the RF too. You can lower your power. Remember, there is a minimum power rule in amateur radio. You use a minimum amount of power possible to carry out the desired communications. And then you could just pause your operation when, you know, when people are near to the antennas. So, you know, if people are walking by, if you're near to a street and you see people walking by, You just stand by, you know. And then you don't need equipment. You could run the calculators, right? The only thing really difficult is SAR, but you know, the RF Safety Committee is doing a lot of work with the FCC to make sure we're not subject to that. You could use a modeling tool such as ECNEC if you can, you know, if the calculations say that how you're non-compliant, so you could still drill down further and eventually reach somewhere to see how much in compliance you can be. So be prepared to do this. It's not difficult at all, and I'm going to show you the calculator, right? And you don't have to worry about the limits for handhelds. You know, the manufacturers will completely take care of that. I'm sure EMCOMM and Kenwood and Yaesu and the others want to keep selling more radios. And we appreciate when they bring out cool new radios. And they will do whatever it takes to make sure those radios are compliant with all FCC rules. And remember, even if you're exempt, you still have to comply with the exposure limits. So it's better if you just do it anyway. All right, common sense. Okay. So that's the end of the slide. So what I'm going to do now is I'm going to bring up the new ARRL calculator and show you some of the changes that have been going on. Let's see here. Whoops. Okay. So you can see my Twitter here. ARRL. You see, I have Joe Biden riding a Jeep and then a ham with a tower. So let's see. RF exposure. Okay. Right, so this is the main RF exposure page. It's chock full of resources. I know there's a lot of section managers in this conversation. People probably come up to you. And listen, excuse me, one section manager recently said how people don't value what he does. I don't agree with what he said. I think that people value a lot of what the section managers do, and I'm really hoping that we could get the section managers more involved, and I'm going to be working to make sure we get the section managers more involved. If people come and they ask you about questions about RF exposure, you could redirect them to this webpage. You know, you can show them your new skills with using the calculator. You can read the book and share your knowledge as well too. We always appreciate when you guys do that, and you know, I'm hoping you guys are more active with educating the members in your sections about this. So this is a new RF exposure calculator. So it's ARRL.org/RF-exposure-calculator. All right. So now, this is the new one. So this is actually based on the old Lake Washington calculator, right? Initially, let me see if I could get another one here. I'll add another tab because we like more tabs. Lake Washington Ham Club. Okay. Right. Okay. So this is the original Lake Washington Ham Club calculator. Now, Lake Washington hosted the calculator, but this was actually written by Wayne Overbeck, N6NB. You might know him. He's a very, very good resource on a lot of things. He wrote a basic program to calculate the RF exposure, and then others like Lake Washington took the program, then they made a website with it. Okay, so let's say I have, let's say for simplicity's sake, I have 100 watts of the antenna, right? My feed line has no loss. And then they tell you the mode conversational duty cycle. Okay. They tell you transmit duty cycle. Antenna gain, let's say 3 dBi. And let's say I'm doing this on 20 meters, right? You can include ground reflex, effects of ground reflections. And here you get the results for the controlled environment, the maximum allowed power density, and the minimum safe distance in feet, okay? This is for a controlled environment. This is for you, the ham. Uncontrolled environment would be something like your neighbors, the people on the street, or people who visit as guests or whatever. Now, let's look at the ARRL one. So the ARRL one is, you know, kind of similar So you do the power at the antenna. Let's say I could do 100 watts. And then what they do is they put a bunch of little things here saying need help with this. And they have like little, information on how to calculate these various things to input in the fields. And then the transmit duty cycle, the antenna gain in dBi. Let's say you do 3 dBi. And then once again, 14 megahertz, include effects of ground reflections. Now you can actually sign up for an email list here. And then you calculate and we'll get the same thing. So the two things I don't like about these, this calculator is that you look at the modes here. Okay, you have SSB 20%, conversational SSB, heavy speech processing, CW, FM, AM, RTTY. I don't see any of the most popular modes in ham radio. I don't see anything like, for example, I don't see FT8 in there, and FT8 is 50%. Now, I could just use conversational SSB 50% and use that in lieu of FT8, right? But, it would have been nice to have that there. I don't think it was anything against FT8. I think it's just a general omission they made because they copied this from Lake Washington. Okay. And you can print the results. So I can go here, hit print results, and then I can put this on a printer or I can save as PDF. I save the PDF and then I can save it. And then I could say RF exposure for 20 meters. I save down the desktop and I have that good to go. So when the FCC inspector comes, I just whip that out and show him or her and said, look, I'm in compliance. They have a set of detailed instructions here for each parameter, right? And they tell you different types of antennas, the gain and such like that, which is a very big help because a lot of people make antennas they don't know. All right, okay. So anyway, that's pretty much it. I could take a few questions. Unfortunately, I have to drop off. And so I'm going to stop the share and I'll pass it back to Dan. Hello, Dan.
Hello, Dan. Where are you?
I'm right here.
Did I put you to sleep, Dan?
No, I was taking care of my dog.
Okay.
Oscar has his hand up.
Oscar's got his hand up. Okay, Oscar, take it away.
Ria, nice to see you. Thank you for your presentation. Really beautiful and
Thank
well
you.
prepared. What I
Well,
like,
so what I could tell you is that this work is basically ARRL Lab. They did this, so you could thank them.
yeah.
So
What if you go back into your calculator, and I was playing today with it, and you already have those numbers that you plug in for the band and so on that you just had. Look at the minimum safe distance that you have, 1.2 feet. Something's wrong.
okay, let me see it. Okay. Yeah,
I hope you didn't erase the numbers, but you can plug it in again. You see?
No, I didn't erase. Yeah.
It's 4.59 milliwatt per centimeter square, and the minimum safe distance is 1.2 feet. That's wrong.
Okay.
So I recommend that you should check that something's wrong. And I mean, that doesn't sound correctly. And I have been checking during your presentation several of the bands, and the distance are not correct.
Okay. Well, you know what? I'll take this back to because it does actually match the Lake Washington Ham Club, right? I don't. Let's see, 1.2 feet.
Yeah.
Could be. Yeah. Let me take this back. You know, that's a good point. I need to do some
And
some
if
detailed.
you go back to your presentation, just to give you just a base, I have to do the calculations by hand. If you look the lambda over 2, it's more, the distance much longer than that. So if you have to be exempt.
Yeah. Okay. So let me take this back to them, to to the RF safety committee, and see what they have to say about that, and I'll give an update.
You just passed the slide that I have the lambda over 2. One more.
Ria, why don't you do this? If you find a discrepancy there, why don't you do a YouTube on it and send me the link to that YouTube, and I'll put it out to everybody with this thing.
Yeah, I want the lab to. I want to give the lab the opportunity to address this. So
No,
it should be checked, and she's very bright. She's checking the example that she has there, and definitely for 5 meters you can go up to 78 watts, and 5 meters is about 15 feet, right?
Mm-hmm.
So that's the reason.
But actually, yeah, okay. So let me let me go, and I'll talk to them. I think we have to see how here. So I did a 3 dBi. Let's say I do 0 dBi.
No, 0 dBi is in a logarithm. It doesn't exist. It has to be 1.
Okay. Let's see here. A dipole, 2.15 then.
Yeah, 2.1 or 2.2. Doesn't matter.
Yeah. Okay. Let's see here. If I get Zoom to stop doing this. Okay.
But it will make any difference.
Sure.
I'm sorry. I don't want to. Just simply the sooner this find out, and because I want to have the calculations and just put it on my notebook and.
Yeah. No. This is good. I mean, and then this is saying 1.14. Okay. Yeah. No, I will take this back to them and see what they say. So no, but that's good. That's definitely good. I'm definitely glad you pointed that out. And if it's a matter of updating the calculator, then we'll do that. If it's a matter of explanation or something, then we do that. But I think no, that's definitely an important concern, because if it's giving you an erroneous number, then you're obviously not in compliance.
I'm wondering if the operating frequency is typed in right.
Yeah. Yeah.
That's okay. They will figure it out.
Yep. Let me see. 29.7. Let me just calculate this.
Everybody's in compliance with that calculator.
Right.
By the way, if you want to get out of scale, you have to go to 100,000 watts.
Yep.
Question says the frequency is supposed to be in gigahertz.
No, it's in megahertz.
Okay.
Yeah.
That's okay. Sorry.
No. Don't be sorry at all. I'm really glad. I'm gonna double check these actually, and we'll see how that goes. All right. Okay. Anything else?
Thank you.
All right.
I do have another question. Before, Barry, hold on, before saying good night. What about, I'm bringing a concern that, what about when we have like amateurs that who live in a apartment building or apartment complex, that you have neighbors, let's say 10 feet away, above you or below you. By the way, the rule says as close as human beings. So that's where people can actually be like amateurs. We amateurs put antennas on the balcony of an apartment and so on. What would be the compliance with that? Because if you follow the rules, that means that you won't be able to work 80, 40, or 30 meters, 20, and even 10 meters. You probably can work VHF, UHF if you do the right calculations. And this is what I'm bringing to the different group to work with this scenario and explain people, because if you push it you push the envelope, you push it to the edge when you have apartments and people are nearby, That means that you cannot work HF at all with your neighbors being so close.
Yeah, so that is definitely a concern, and I think you know, the idea is that they don't want you to work that close to people, one, but at the same time, remember what I said, there are several layers of this, right? So the first one is that you calculate, if you can calculate an exemption to see if you're completely exempt. Failing that, you can do the modeling with the MPE, maximum permissible exposure. And then failing that, you can then proceed to detailed modeling using NEC and other methods.
So in 50 meters, you have to be 4.5 meters away or higher to be in compliance.
Right.
So your neighbors and the next of the balcony that they can be sitting there, they will be, the emissions will be higher than the allowed.
Right. Yes, that's correct. Yeah.
So
excuse me, this is W6ET with a question.
Yes, go ahead.
So Oscar, I was just curious, wasn't that distance that was shown the minimum distance? Otherwise, you had to do a full calculation. It wasn't a prohibition of operation at that distance, right? Because if, let's say, you were putting out 1 milliwatt, that would be fine. So it just means you have to do the calculation. Or did I misunderstand? Over to you.
Yeah, but what normally people use, let's say 1 watt, 10 watts, 100 watts. So this will be immediately to be considered.
Agreed, but are you saying that those distances, the wavelength divided by 2 pi, are if you're closer than that, you believe that's an absolute prohibition on operation?
That's why we have to do the whole exercise and calculate it. If you do the calculation for 50 meters that she died, you need 4.5 meters with the maximum allowed power of 78 watts. That means that you are definitely already irradiating the neighbors. And that is in control that the emission drops down also.
Right, and of course, I guess you could mitigate that to some degree by having an antenna with a directional component, but I understand. Thank you. Sorry to interrupt.
Yeah.
No, those are good questions.
Or, well, the directional antenna is one. The other thing is you could lower your transmitter power. You can restrict your transmissions to when they're not there. You know, or you could use a different mode with different duty cycle. So all of these things are different options. But you know, if you're near to people, you're definitely going to be affecting them.
And also the regulation requires that it's the shortest distance of the antenna.
Right. Correct. Yeah. So like, right. So if it's like a beam antenna, you know, you're not calculating from the back of the beam, you're calculating from the forward direction, the closest point.
Thank you, Ria.
Yeah.
All right.
You know, this is confusing to me to some degree. I can imagine what it is to a brand new ham just getting started. But this conversation we're having right now on RatPack is what I like about RatPack. It's why I like it open rather than, you know, YouTubes are great and webinars are great, but it's kind of hard to have these kind of discussions. We cover a lot of ground doing this. I'm still wondering about the new hams. You know, let's take, for example, field day or exercise. You know, they exercise or areas exercise. Then it gets kind of crazy in a quick hurry. Yeah, any comments on that, Ria?
You mean in terms of like field day exercises for, you know, with the RF exposure and such like that, or?
Yeah. When you have exercises or field day operations, all that kind of good stuff, man, it get crazy trying to do these calculations.
So that's a good point. So generally for field day, there's a huge emphasis on safety. They want you to have a safety officer and such like that. I think one of the new duties of the safety officer was to ensure that the site is in compliance with FCC RF exposure regulations. So you would notice that some sites, what they would do is they would probably put like markers or caution tape around, the area defining the minimum distance. Like for example, at 5 meters away, and they could basically, mark that off. So it's not nearby to people. So that is one of the things they got to do. And they also need to also keep, what they should have done is like in pre-planning for field day, or even when they get on site, just see where they place the antennas, measure them, right? Or, do the RF exposure calculation, and then place the antennas a minimum distance away from the operator and bystanders. Of course, the operator will have a different set of parameters because they are controlled exposure rather than uncontrolled exposure from bystanders. So if you're operating somewhere like a park, you want to place it away from where other users of the park are, first of all, and you also want to place it away from the operator's tent.
If you have a planned event like a field day or something like that, you can do that fairly well. You get together and work it all out. If you have an exercise or worse yet, an actual emergency of some kind, and you're running off to where the bridge broke or the dam broke or whatever, and you've got people running all over the place, and your job is to provide communication from there, and maybe others are doing the same thing. That's when it gets hairy in a hurry, because you don't have that pre-time to set it all up, mark it out, this kind of stuff.
Again, sorry, you kind of broke up a little bit, Dan.
Oh, I'm sorry. I'm saying that if you have the ability to pre-plan, like for field day, this kind of stuff, you're going to a park, you're going to wherever you're going to be, that works out fairly well. Still a pain in the rear, but it works out fairly well. If you've got an exercise, or worse yet, an actual emergency of some kind, where you show up to someplace and you're at the emergency, you're at the heart of the thing, or at least a busy point, people all over the place doing different things, other people trying to communicate as well, that's when it gets hairy, really hairy.
So to that I say, I'm going to give you a couple of alternatives here. One of them is that in a real life or death emergency, I think that RF exposure, a little bit of RF exposure, is the last thing you're going to care about if you're in the process of saving lives, right? One. Two, if you're even if you do have to worry about, for like a long-term deployment, right? The calculations, the calculators are quick and easy to use, provided they work properly. And then you could just have that and then determine minimum distances. Obviously, if your operational situation demands that that the antennas have to be closer, then I guess you're not going to be able to be fully in compliance. But remember, as I said, this comes in layers. You have the exemptions, right? Then you have the MPE limits, and then beyond that, you can do modeling. The other thing I like to say is that if you know that you have a certain setup that you have, like for example, you have a vehicle, a trailer, a comms trailer or something like that, that you're going to deploy in the field, why not ahead of time? Because you definitely know the type of power and the gain of the antennas on it. Why don't you ahead of time, right? Go and do all the calculations, and just have that on hand. So if you do have to deploy, minimum safe distance, because for other things you definitely know the parameters. Like for example, what voltage your radios operate at, what type of antennas and what type of connectors you have. So this is just another thing you have with the documentation of your field gear, your go bag, or your your comms trailer, your tower trailer, your antenna, your portable deployable kit for emergencies and such like that.
Okay.
So, you know, it just is one more element to add to planning, you know. I know hams love that.
Okay.
Yeah.
Okay, but
I
kind
mean, but I mean, Dan, this is the whole reason you do these presentations, right? So we could plan for, you know, for any eventualities.
yes, yes. And that's the whole, and I go back to this openness. I like open presentations like you're doing tonight here, Rhea, because it gives everybody a chance to communicate, to participate. I love it. We're kind of running on the wild and loose. We don't normally let it go this while, but we haven't had a lot of interruptions. Are there any other questions or comments?
Yeah, remember, I'm not offended by any comments. Okay, you know, if you tell me I'm wrong, I'm gonna look and see if I'm wrong, and if I'm wrong, I'll admit I'm wrong. So don't feel bad. Don't feel you're gonna offend me by saying any
No. You got thick skin there, Rhea. But I was looking at anybody else here got any comments they want to add to this presentation to ask Rhea or whatever.
Diana had a comment for Rhea. Do you think a worksheet might the ARRL could develop that could be used in the field?
So that's a real good question. I'm going to take this back to them, saying, you know, a worksheet or an Excel sheet or, you know, a spreadsheet or something. So, you know.
Okay.
Yeah.
That's good.
Okay.
That's all. That's everything in the chat. If someone wants to know, would an RF meter be something that would be good to have, and what kind?
RF meter. So you mean like a field strength meter or like an RF ammeter?
Jed, you want to come on, unmute, and ask?
Go ahead there and get your hand. I muted you because you were popping in there. Go ahead, Dan. Hello, Dan.
You muted, so.
Yeah, no, that wasn't me that asked that question. I wanted to mention that I did go look at the calculator they use because I was curious whether the frequency really was supposed to be in gigahertz, and it's not. It says megahertz. And I've never seen a presentation that I'm going to look forward to the epilogue as much as this one.
I love it. I love it. Rhea, as soon as you have stuff, we'll make arrangements for you.
Yeah, you don't post anything. Well, I think I'm a fanboy, Rhea. So when you post something, I check it out as fast as I can. And so far, you've been pretty on the spot, and I'm curious what the resolution of this discussion is.
So the resolution of this discussion is that there is none. What's going to happen, what is happening now is that the lab and the RF Safety Committee, Ed Hare and these guys are working with the FCC on updating the documentation for hams, 1, and 2, also trying to get us a little more clarity in the regulations, 1, and 2, trying to get it so it's not cumbersome for us, right? And that is a major thing. We don't want something that'll be onerous because we're not like one of these big wireless carriers who has like, you know, full-time staff of people doing this. We are just individual radio amateurs. We want something simple. We want something non-burdensome.
Very good. Very good. Is there any more in chat there, Barry?
Nope. I'm trying to get a clarification of what kind of an RF meter. He says no idea. He's been putting up off-site antennas and he had no idea there might be issues. Okay. So
yeah. So these, you know, the RF field strength meters, I don't think those are going to be very valuable because they will tell you field strengths, but then you have to go and like measure it all around and see. I think the better thing would really be to comply with the MPE limits, which are the simplest thing. You do the calculations. And then failing that, you could use neck modeling using some of the available software. So
okay,
that's it. All right. All right.
No one else has their hands, so it looks like we're good.
It does look like we're
all right.
good.
I need to drop. Yeah, I need to drop off now, unfortunately. But thank you very much, and you know where to find me.
Yes, we do, everywhere.
Well, that's how it goes.
All right. Well, it's a very good presentation, Rhea. I thank you for coming on board. And we're all going to look forward to the update on this, like Dan pointed out. And whenever you're ready, we'll put you on. We'll make a spot for you.
Yeah. So Christian KD2LIN says he referred to the presentation from ARRL. Big surprise to see that the actual calculator was labeled for megahertz. I'm gonna call up one of these guys, to see what exactly the deal with that is, and I'll get to the bottom of it.
Okay. Appreciate it very much. And that is why you're everywhere, because everybody needs you.
Right.
All right. Oscar's got a thumb up. You got to go. So unless there's a question real quick for Rhea, we'll plug. I don't hear any questions. Okay, Rhea, we're going to let you go. Appreciate you very much for coming on. As usual, good job. Appreciate you, lady.
Thank you, Dan, and thank you everybody else, and thank you. And I'll follow up with the answers to these questions, hopefully.
Okay, sounds good. Thank you very much. 33
Bye.
everybody.